So logs. Right, Jim. You said it's the inverse of exponent, right? And inverse, you understand it as, you know, if you have a function that takes x to y, the inverse will take the y and bring it back to x. Okay, so that's one interpretation. But this interpretation alone, I think it'll be hard for us to really know what it means as a whole. Okay. First of all, this right here symbolically means this. You agree? That f at x is equal to y.
Yeah.
So symbolically, then this must be true. F inverse at y. So if you plug in y into the inverse, you should get x. So this picture symbolically means this. Okay. So if you have y is equal to 2 to the power of x, okay, that means if you plug in some function, you plug in y, you will get 2 instead, x instead. Agree? Okay, so this function, we define it to be log. So instead of writing f, we write this. Okay, to make it an inverse function, right, you have to make your range, your result, your domain. So we have to switch the x and y value. So look, you get this. Okay, so symbolically I've just demonstrated that log of x base 2 equals y is the inverse of y is equal to 2 to the power of x. Now lastly, graphically, right, you know, graphically y equals 2 to the power of x. And when it's 1, it's 2. 0, 1. When it's negative 1, it's half, right? So it looks like this. Now, functionally, this means when x is equal to 1, y is equal to 2. So it has to be backwards now. When x is equal to 2, y will equal to 1 in the inverse function. When it's 0, 1, so it'll be 1, 0. Right? Negative 1 zeros. So negative 1 half, so it'll be half negative 1. X-axis is the asymptote, right? So that's going to be the y-axis. Okay, so this simple statement of, you know, inverse, right? Log is the inverse of exponential function, like 2 to the power of x, means this is symbolically and it means this graphically. Okay, you have to understand that. And of course, if you put different number at the bottom here, like a, that means x is equal to a to the power of y, right? So this is a definition.